Okay, I wanted to show you guys how I think about ecological succession. So I'm going to take sort of some notes for you. It's probably a good idea for you guys to do this too. So, ecological succession versus evolution. This is the way that I think about it. Now you're going to notice I'm going to draw a lot of things. I'm going to color code. I'm going to chunk things up. And that's because neuroscience tells us that our brains learn best that way. We are highly visual creatures. So while some of you might be used to taking notes all the time just in word form, know that your memory works far better if you even create sort of simple images to show the concepts. So when I'm thinking about ecological succession, what I'm thinking about is the difference between simplicity and complexity. So if I kind of have something almost like a triangle. So what I have is a simple ecosystem down here. It's building in complexity until I have what's called a climax community, which would be right here. Now, what I'm looking at is a change in the entire community over time. And with the exception of kind of this like first little bit where I don't have, soil or much to build on, I'm not focusing on evolution per se. I'm looking at the different species that are in here. So if I just sort of represent that. So let's pretend this is one species. Now you'll notice it's high in population earlier. And as time goes on, it's still there. It's just in a different form. Now I know that I also have different organisms. So again, these little green ones are always here, but maybe there's a lot more of them in here, and the environmental conditions are just right for this population to now explode, and there's still more. And then now maybe as we get higher, now all the things that came before, again, I still have these organisms back here, but their numbers change. Who is able to thrive changes over time. And, again, this is just a representation with like 3 different organisms. Obviously, it's way more complex than that. But I'm looking at the change of the community over time, not the specific populations, but the population amounts. So really, you can think of it almost like changes in the food chain, almost. I'm looking at the entire community. And its change over time. Okay, now this is also reliant on some of those abiotic factors that we've talked about. So that's a good thing to write down too. So it's reliant on abiotic factors. So especially if we're thinking back in time, 4.5 billion years ago when the Earth first formed, and we're thinking of, how organisms came to be, and what did they need? We need sunlight. Well, at some point in our Earth's history, we had huge amounts of volcanic eruptions, which blocked out a lot of the sun. So that's a problem. That's something that we need. We need oxygen levels. And that came from the succession of having a lot of plants, and also, oh my gosh, stromatolites, those also were part of that as well, a big part of that. We also need carbon dioxide to build some of those plants, so there's a feedback loop in there. We need various minerals for soil content. Also, for making ions for our muscles and just about everything else in our bodies to function. And a lot of those come down to things like calcium and magnesium. So there's kind of this abiotic to biotic ratio to kind of consider when we're starting at this place right here. So in this very beginning, when we don't really have a whole lot of organisms, or like this is like an extinction event. Or maybe like this is the beginning of the planet. You can think about that either way. These things have to build. So this right here, this first part of this is going to be your primary succession. And that potentially could take a really long time. As I mentioned in the video, that could potentially take millions of years. Now, once you have some of that soil, and that soil along with it isn't just mineral anymore, but there's a lot of decomposition that happens, then you're starting to get into the secondary.